So in this problem, we're being asked to think about disjoint and not disjoint and independent and dependent. And so in the first example, you pick one guy, and A is the event the guy is colorblind, and B is the event he is not colorblind. He has to be one or the other. So those two things cannot both happen at the same time. So the events are disjoint. They're mutually exclusive. Right? They can't both happen. That is the question that you should ask. What is the question that you ask when you're checking for independence? You ask, does the probability of one affect the probability of the other? If the answer is yes, they're dependent because they depend upon each other. If the probability that the guy is colorblind is, I don't know, 20%, then we know that the probability that he's not colorblind must be 80%. So the probability of one affects the probability of the other. Those events are dependent. They're not independent. Okay? In the second scenario, the researcher selects two guys. And now A is the event, the first guy is colorblind, and B is the event, the second guy is not colorblind. Okay? Are A and B joint or disjoint? Well, could they both happen? Could it happen that the first guy is colorblind and the second one isn't? Absolutely. So they can both happen. They're not mutually exclusive. They're not disjoint. Are they independent? Does the probability of the one thing affect the probability of the other thing? No. The first guy being colorblind is not going to affect at all whether or not the second guy is. So these events, if the men are truly drawn at random, then those two events are independent.